So another really good use case for and this would work iteratively as well, but recursive, this would be a really cool solution. Let's say you had all of these numbers here and they were arbitrarily nested, right? Like you can see here, this 14 here is pretty nested. You could write this as iterative and you could unwrap arrays and things like that. But this also you could also just call a recursive add call on all of these. And this would work really well. So let's actually give you a shot of doing this. So I'm going to go edit here on CodeBot or Sandbox. And we're going to pop over to Code Sandbox here. And we're going to go to Files. And we're going to go to Nested Addition. So it's in recursion. There's one here called nestedarrays.test.js. And what I want you to do is I want you to go and I want you to write code in a recursive fashion that takes all the numbers in the array and adds them together, right? So this should be 10 plus 12 plus 14 plus 1 plus 16 plus 20 plus 10 plus 11. And I want you to use recursion. So one, you can definitely use flatten. That's cheating. Do not use flatten for this, or flat, or smush, depending on when you started writing JavaScript. But I don't want you to do that. I want you to write this with recursion. So we're going to give you just a bit of time for this. But just think about first, what's your base case? In this case, your base case is if you're adding a number, right, and not adding an array. An array is when you would recurse more, right? And then, yeah, then you're just going to return a number at the end. I remember the first time I learned recursion, and I was a buddy young lad, young strapping lad in Bountiful, Utah. My brother would make me write code before I could play video games. And just the moment that it clicked for me, I was like, wait, I call the function inside of itself. The call is coming from inside the function. That's funnier than I thought it'd be. Anyway, I don't know. It just melted my mind. It made me feel like I had superpowers. So it was a cool experience for me. Hopefully, it's a cool experience for you. I imagine some of you probably have written recursive functions before, but for some of you, it might be a really cool experience. All right. So I'm going to have a let sum function equals 0. And I'm going to say for let I equals 0, I is less than array dot length I plus plus. And I'm going to say const current equals array of I. And then I'm going to say if array dot is array. This is just a nice little helper function that lets you check if something's an array. Then we need to recurse, right? So we're going to say sum plus equals whatever comes back from nested add of current, right? Else, otherwise it's a number. You can assume it's always a number. Sum plus equals current, and we keep on our merry way with our for loop. Then down here, we're going to say return sum. So our base case, interestingly enough, is not at the top. I would say it frequently is at the top. I would say usually is at the top. But in this particular case, it wasn't. OK? But the base case is here, which is to say that it's not an array. Right? And then we keep going. And then here, all you can see, it's going to come down with the nested add, and it's going to call this again and again until we eventually get our answer. So let's try this, make sure that it works the way that we think it should. And recursion, nested arrays, and it works. Now you absolutely, totally could do this with iteration and just on kind of unpacking arrays that way. But this is actually a nice, kind of elegant solution that we use this nested add function. And I would say this is totally fine. You might get a little bit more performance out of a iterative solution, but even for pretty deep arrays, this should be plenty fine. So, any questions about nested add?
Good question. What would be the time complexity for this?
Good question. The time complexity, yeah. So what's the time complexity of our solution here? This is kind of an interesting one to model because the depth of the recursion is not going to be dependent on how long the array is, right? The depth of the recursion is going to be determined by how nested these arrays are, right? So you can see here, this only has a length 1, but it's nested a whole bunch, right? So we'd actually probably have to introduce some sort of third variable here, or second variable. So we have n. Typically, the next thing you introduce is k, right? So this would probably be of complexity n, because we would certainly have to loop over everything in the array. Plus, you'd probably have to times it by k, which would be the depth of recursion. So nk, probably. You might need to check me on that one. It's kind of hard to model some of these things as big O, because some of them don't lend themselves super well to big O analysis. But that would be my guess.